Today's webinar, of course, is New Innovations for Saving Energy in Buildings Through Behavior Change. And my name is Ruben Sussman. I direct the Behavior and Human Dimensions program at HCEE, or the American Council for an Energy Efficient Economy. And importantly, I'm here today because I co-chair the BECC conference, or Behavior, Energy, and Climate Change. HCEE, of course, is just one of three convening organizations, the other being CIEE and Stanford. So if you're interested in this topic, I recommend coming to the conference itself. We're only 2 months away now, and this year's theme is engaging all voices. If you're thinking of coming to the conference, either the virtual day or the in-person full experience, please register. Prices do go up by $100 on October 1st, so register by the end of this month. Now, just a little note about what the conference actually is this year. As I mentioned, November 9th, the first day is going to be totally virtual. It's like the classic virtual conference you've come to know and love from BECC for the past 2 years. In addition, though, we have the in-person experience, which you may remember from 2019. It's going to be in Washington, D.C., and you get to meet 300 of your favorite people, 400 of your favorite people, and interact in person. So the one registration gets you into both, but if you want, you can just register for the virtual opening day also. I would be remiss if I didn't draw your attention to our sponsors. Our sponsors are really, really important for the conference, not only because they help the conference exist, but this exact webinar. So if you want to see these webinars in this conference continue, or if you just want your name on this list so everybody else can see it, contact me and I will help get you hooked up with a sponsorship. And before we get to today's webinar, I want to mention that our next webinar is October 26th, next month. And it's on equitable digitalization of energy information, matching the need to the challenge and changing behavior. We'll have Carlos Martin joining us from Harvard and our very own Therese Peffer from UC Berkeley and CIE. And before I get to today's webinar, I just want to say I'm seeing all these chat messages coming through. Thank you so much for coming in. You're interested. Martin says he's interested. He's an SEM program manager. Len wants to find the least cost ways to reduce building energy use. Julie wants to know, this is our first webinar, so thanks a lot for coming out. Looking forward to DC, definitely here for the music, so that's much appreciated, of course, and involved in behavior and climate, everything. So I'm seeing a variety of folks here. I'm very excited to now turn it over to today's speakers. Oh, wait, one last order of business before I do that. That was a psych out. Logistics, remain muted during the presentations, but if you want to turn on your camera, we're a very social group. It would be awesome to see everybody's on. Feel free to turn on your camera, even though you are muted. Use the chat for questions and discussions throughout the webinar. You can see the chat button on the Zoom bar. Probably most of you are familiar with it by now. You can use that to ask questions or have conversations with everybody, or you can even specifically chat some individuals within the webinar, other people you see. And we'll have time for all your questions after the presentation. I shouldn't say all your questions. I will do my best to get all your questions answered. But yeah, putting your questions throughout the chat, throughout the webinar into the chat, and I'll ask them after everyone's presented. So today's presentation will have 3 presenters: George Zavaliakos, the VP of Technology and Data Science at Sense. Then I'll turn it over to Shelby Ruiz, Research Project Manager at Washington State University. And finally, Peter Crabtree will wrap it up. He's a visiting project scientist with CIE Citrus at Berkeley and the BEST Center. I'll let him explain that. That is the BEST acronym. All right, so thank you so much for joining us. George, please go ahead and take it from here.
Okay. 1 second. So, okay, I hope you're seeing my slides. I'm trying to hide the Zoom controls. Can you hear me okay?
Yes, thank you.
Okay. Hi all, I'm George Z, VP of Technology here at Sense. And I'm gonna, the next slides, I'm gonna present the results of a study we did with OnConnect last year to figure out how to maximize demand response savings using real-time information that Sense can provide. So before we start, I'm going to give you some background on Sense. Sense is a retrofit hardware device about the size of an iPhone that is installed in the electrical panel in the home. And we use machine learning with models trained in the cloud to give real-time information to the consumer. And what you see here on the right is kind of like a video of our app that shows every bubble is a device running in the home. And as they turn on and off, right now the garage door is on and it will go down and it will disappear. And the size of the bubble is proportional to how much consumption how much energy it's consuming every moment. Okay, so this is what the consumer is seeing. So a little bit more on Sense business. So today we are selling in Amazon and our website as a $300 retrofit hardware. We are installing about 100,000 homes, and this real-time view in the homes has turned out to be tremendously addictive. We have amazing engagement. So people that buy our product, 57% of people that buy our product still use it a year later, and on the average, they open the app once every 5 days. Okay, but our business plan is not to be just a retrofit hardware. Well, we are integrated in the next generation meters with Landis and Gear, and a deployment of 1.7 million meters start next year in New York. That is going to be the first time that we're going to be able to test how much real-time information and engagement can affect a large population. Okay, now to the specifics. We did this pilot with OhmConnect, and we wanted, both us and OhmConnect wanted to assess the impact of providing access to real-time energy information. So in order to do that, we recruited among 4,000 eligible Sense users, and on the right you see kind of like the visuals that of the offers they got, which was basically get the incentives from Sense and from OhmConnect and enroll as normally with Sense. So I'll start the presentation kind of like almost in reverse by saying what the bottom line was. So of these 4,000 users, about 12% visited the landing page, which is a good number, and about 5% of them completed the registration and connection with the utility. Okay. Then they participate. We monitor them over 3 months over a number of demand response events. And on the average, we saw savings of 313 watts per user per event, which was 18% savings as percent of baseline. And this result was amazing. It was about 2.5 times more than the savings that the typical OhmConnect customer would achieve. Okay. And the story that I'm going to present in the next few slides is that the reason we were able to achieve better savings is a combination of 2 factors. Awareness, because if you know what is spending the energy, you know how to react, and engagement, because the more you engage and the more you learn and the more opportunity you have to act. Okay, so quickly, insights about engagement. A typical Sense users open the app every 5 days. The users that participated in the Ohm study opened the app every other day, so about 2.5 times more engagement. And of those users, the ones that saved the most opened the app in 2 out of the 3 events to see what's happening in the home. And in a survey we ran post the trial, about 3/4 of the participants agreed that getting notifications from Sense is important. And what did the users do with the information we're providing? About half of them said that they stopped big energy hogs. About 1/3 of them said they opened the Sense app to see what is running at any point in time to react. Then they turned the AC or change the thermostat, and a lot of other kind of like energy saving actions. Okay. When we asked them what else would you like to have, they asked for warnings during or before home hours about what is running in the home and consuming a lot. They wanted to know if they were below or above their average. They wanted recommendations about what devices to turn off. And they wanted to know which of those devices contributed more to the usage, all of the things that we're trying to work to incorporate in the app. Okay. What were the insights from the device disaggregation? So since we are running this machine learning technology that detects what appliances are running, we can actually deep dive and see exactly what our users were doing. So on the left diagram here, you see how they modified their AC behavior. So of our participants, we grouped them into three groups: the non-savers, or the ones that participated but were kind of passive; the savers, the ones that participated and achieved the most savings; and the middle of the group that we could not classify. So most of these events, DR events, happen in California in the end of the day when the heat is high and air conditioners are running. But you see that blue bar is before, orange bar is during the event, and green is after the event as night comes and the temperature is dropping. So this is for non-savers. And what you see that savers did is that they practically minimized their AC usage during the event, and then they compensated by cooling their home afterwards. Okay. On the what actually happens with individual devices, we looked at the big energy appliances, ovens and stoves and dryers. So for the non-savers, about 20% were running something cooking during the event, and about 12% was running laundry during the demand response event. And you see that from the savers, they were able to reduce the usage of big appliances by a factor of 4, because what we see is that they open the app, they see a big bubble that says the oven is taking all the energy right now, so this is a good opportunity for me to save energy. One more insight about notifications. We also send notifications to the users an hour before the event and 5 minutes after the event starts, so that they can to encourage them to open the app and see what is happening. And during the first week of the pilot, we ran an A/B test where we withheld notifications from about a third of the users. And you can see that there is a significant impact of notifying the user and helping them to be engaged. The savings from the users from the side that did receive notifications were about double the savings from the users that did not receive notifications. Okay, closing up with the same slide that I kind of started. The bottom line is that by providing real-time information to the user about what is running in their homes right now, right during the demand response event, we were able to achieve 2.6 more savings than the typical Home Connect consumer. And the story for this is that if you can get your consumers engaged and you provide awareness about what it's running, then you are able to achieve higher results in demand response. Thank you. This is my slide, and I guess questions will be at the end after all presentations.
George, that was fantastic. And I can't believe how quickly you went. That's wonderful. There are already some questions coming in, but we're going to turn it over first to Shelby, who's going to tell us a little bit about her program. And remember, keep putting those questions into the chat, and let's keep the conversation going. Thanks, Shelby.
Awesome. Just a second here while I get my slides up. All right, can everybody see my screen?
Looking good.
Awesome. So thanks, George. I'm actually going to be talking a lot about engagement and awareness as well. So thank you for setting that stage, and you had a great presentation. So today I'm going to be talking about a program that we run here on WSU Pullman's campus that has been supported by NEA's, the Northwest Energy Efficiency Alliance Better Bricks program. We've completed our first year of implementation of this project and are continuing doing that again this year and this semester. And I'm going to be talking a lot about our engagement activities, some of the physical materials that we use to talk to people on the ground, the building occupants themselves, and a smart strip study that we've piloted and are continuing to do this coming year. So I'm just going to dive right in. You'll be able to see our team here. I'm here in the middle, a couple haircuts ago, but we also have a couple undergraduate and graduate students helping us out with some of the analysis. And Julia was actually supposed to present this today, but wasn't able to be here due to travel. Some of our project goals and the pillars of this project are reducing energy use, obviously, that's the #1 goal, building a community of folks on campus that are really interested in the sustainability factors that affect them on a day-to-day basis, and also improving their health and well-being as they're in these buildings, including comfort, thermal comfort, visual comfort, giving them resources to not only help themselves, but help their peers. So I'm going to breeze through a couple of these engagement material examples that we have, but we talk a lot about space heaters. It's a common issue that we have on our campus. We also promote physical well-being, getting people outside during the weather that is actually suitable for it. And you can see over on the right side of the screen our promotional poster for getting people recruited for our Smart Strip study. And that's the majority of the focus of this presentation. A lot of this is also reminding folks that we do have fire and safety policies in place. So getting them to use acceptable space heaters and acceptable devices in their offices, whether they bring them from home or they're getting them on campus. So another example here is our newsletters. And we do this on a monthly basis, usually 2 to 4 pages each. This is just covering some of the educational content that we deliver. So on campus here, we have central systems, including central chilled water and central steam. Your typical building occupant, especially at a college administration level, may not know how these systems work as well as your typical engineer or peers in what we do. So part of my favorite examples of this are actually going and talking to people and saying, hey, this is what's going on and this is why you may be uncomfortable. How can we find a solution that works for you? And typically they get it and they're excited about it. So just some visuals there. The actual meat of this presentation is our Smart Strip study. And you can see the actual device that we use down here is a BN Link Smart Power Strip. I just call them glorified surge protectors. They do have a timed feature, so they switch on and off depending on the devices that are on there. We're collecting data about people's work behaviors, their times that they're on campus, typically 7 a.m. to 6 p.m., giving them a little bit of wiggle room on either side. And right now we have a little bit more over 91 smart strips, but we have the analysis for that number, so I'm going to be talking about that today. And when we go into people's offices, we collect a lot of information, determining the equipment that they have. We take pictures of those UL labels so that we can cross-verify in case we don't collect all the information we need. And we do measure the consumption of the actual devices themselves. But what we find to be the most beneficial factor here in making these estimates is their use schedule. So we collect information about what days people are on campus, what times they are, how often they work from home and maybe remoting into that computer. They have printers. And then down here on the bottom left, we also collect information about their comfort. And we use that as a tool to advocate for them to facilities if there's anything seriously wrong with their thermostat or with their cooling system. We collect information about how frequently they use space heaters, if that's an all year thing, or if they only use it when needed. And this has been really helpful in getting an idea of what's going on in our campus buildings. So from that data collection sheet, we put it into a massive Excel document with equations that take their personal use data, their behavioral data, and try to quantify that a little bit. So you can see we have computers, we have monitors, speakers, space heaters, printers, all of the works. And over on the right side, we're calculating their daily typical use before we install the smart strip compared to how that changes when we essentially cut power to those unnecessary devices during off hours or unused hours. So there's a couple different metrics here initially, and we're on a semester schedule, so we're programming it that way. In the first semester last fall, so this time last year, we were able to get 43 smart strips into offices, so that's 43 offices. And you can see the pre-smart strip estimates of what we assume that they're all using, how many kilowatt hours that is, what it actually is costing the university to operate, and then the post smart strips. So that's assuming that we're turning off some of those devices for certain hours of the day. And then we're making that into savings. The overall goal for the first year of this program was to have 100 smart strips in place. We didn't quite meet that and only got about 91 in before this first phase ended in June. But overall, you can see that we're saving about 42 to 43% just from cutting power to those devices. And if you think about how many people work at a university, if we could get these into more offices, what that really could be as an impact long term. Here, for those who are visual, we have graphs. The red lines are our funders' estimates of what we wanted to be able to pay back and save over time. You see the 43 as this farthest to the left line, the 91 that were actually installed, and then the 100 smart strips. That is our goal, which we are very close to at this point. These red lines, as far as cost and kilowatt savings, are just set by our funders, as I mentioned, but that initial year one savings has already been met. And then our long-term payoff for both of the programs are going to be a year 7 and year 8, which was a lot sooner than we expected, which is very happy. So an example case of what this actually looks like in people's typical offices, we call this man Mr. 4 Monitors, because he has 4 monitors, a printer, a coffee machine, a pencil sharpener, lamps, 2 space heaters, among other things in his office that are consuming a lot. So our initial estimate was that he is spending the university almost $7.50 per day and getting upwards towards that 100 kilowatt hours. And through different interventions, whether that's reducing the amount of space heaters that he has or actually replacing it with something that, 1, is compliant with WSU fire policy, but 2, actually more efficient in warming his seat as the reason that he has the space heaters in the first place. And you can see a significant daily cost savings back down to about 50 cents per office. And as I said earlier, if you could imagine, we have about 12,000 university just staff, not even considering students or faculty. So if you can multiply that annual savings from 1 person across that many offices, or even half of them, how significant is that, and where are we leaving energy on the table? So overall, some of our plans for additional savings include shifting that window that we allow people to come in early or stay late, teaching them how the smart strips work so that they can do those overrides themselves, and just identifying some of that high draw equipment to replace or get them better options or remove entirely, are definitely top of our priority at this point. And then we're also working with WSU IT. They do a lot of overnight computer updates, and they don't want us to be able to turn off those computers in the evening. Also, a lot of folks are just really bad at saving their work. So in order to keep everybody happy and things moving at the university level, we actually have all of their computers in the always on position. We're working with IT to find a solution that would work for them, that we could capture more savings through their actual desktop computers. A lot of them are microcomputers. And then pushing more engagement, more incentives, including people in this agenda so that they're motivated and eager to participate. And then moving forward, as I said, we're doing this again this year. Our goal is to install 200 smart strips. We have 2 new buildings, technically 3, that are mostly faculty and staff offices as well, more on the academic side. And we're recruiting new energy champions who are our #1 people in every department to communicate our message throughout their staff team. And I say enforcement and encouragement here because we're telling them a lot of different things. A lot of it's education-based, saying, hey, you know, your role in this energy profile of the university matters, and here's how we can make you comfortable and save energy. And that tends to be the message that resonates with the most people. Additionally, in long-term plans, we're hoping to get this in every single building on campus. Right now, we're looking at about 6 or 7 buildings, and then also expand this into the residential hall setting, looking at more students at home, because we know that people's energy use and when they're paying the bill is going to be a little bit different than when they're coming to work or to school. And through that program, we're planning on looking at water consumption as well, trying to get people to be more conscious of our environment in that way. So I also am wrapping up a little bit quickly, but just wanted to say a big thank you to Nia and Better Bricks, as well as WSU Facilities, for engaging with us and allowing us to be on the ground while they're trying to tackle some of the bigger issues at play here. And if you have your phone out, you're able to scan that QR code and it'll pop you into our website where you can look at all of the resources that we have available right now.
Thanks, Shelby. Again, great job, super interesting stuff. And there's already some great questions coming through on the in the chat. And so thanks, keep those coming. I will, and I recognize a few of these names from like a blast in the past. Matt Greeno, I haven't seen you in ages. So it's really great to see everybody in all the chats that are happening. Our last presenter, certainly not least, is Peter Crabtree. So I'm going to turn it over to Peter now to bring us home. Peter, go ahead and share your screen.
Okay, am I sharing the right screen?
It's looking great.
Okay, perfect. Hello, everyone. I'm Peter Crabtree with CIEE Citrus at UC Berkeley. I'm the principal investigator for the BECC Center, which is a National Science Foundation funded center of excellence, focusing on building efficiency, HVAC, and so on. I'm going to be talking at kind of an industry level, of analysis here, looking at commercial buildings and how we can change behavior to address energy efficiency and related issues. First of all, let's talk a little bit about commercial building trends. And I think we're all responding to that first bullet there, the need for carbon reduction across the board. In buildings, this has lots of implications, particularly for greater energy efficiency and decarbonization. And we're seeing trends toward the need for heat pumps, for example. We're also, especially in California, looking at more grid interactive energy management requirements as we shift more towards renewable energy. And of course, there are new tools and technologies. There's the healthy buildings movement, and we have the whole overlay of post-COVID health and wellness. First thing we should know is that commercial buildings, commercial construction, and building operations are legacy industries. They are governed by traditional organizational structures and norms, and their behaviors are guided essentially by traditional business models. And those of us who have had experience with construction can understand what I'm saying. Now, definitely architecture, for example, has done a lot with sustainable design, and those kinds of things are changing. There's new equipment being used, et cetera, et cetera. But underlying these organizational structures are business models that haven't changed all that much. And when you get to the transition from construction to operations, there are some very critical inflection points. For example, I've listed a few. Is there a complete set of documents? Are buildings fully commissioned? There's a lot of controversy about what commissioning means. Does it mean turning the equipment on and making sure it's actually working? Or does it mean going through very carefully and determining that it's actually working as intended? And there's a lot of differentiation about that. How much have operations staff been engaged during construction in terms of making recommendations about equipment selections and operational processes? And have operations staff been adequately trained on new equipment and control systems? Or was it just Friday afternoon for 2 hours? These are very important questions that ultimately affect the behavior of people who will have to spend the next 50 years operating the building. We see important technical trends, including new technologies that are incorporated into HVAC equipment, improved building automation systems and energy management systems technologies, advanced standardized sequences of operation that ASHRAE 36 is advocating. Lots of people are developing new data management and fault detection tools. Buildings are literally huge data warehouses now, and a lot of that data is just kind of sitting latent. And so people are developing tools to try to pull that data into actionable information. There's also now an interest in projecting the benefits of IoT and AI, even thinking about self-diagnosis and self-repair of equipment. And finally, there's this kind of overlay that if we can automate solutions, that will reduce human intervention and errors, and which is premised on the idea that people will reduce system complexity to the level that they understand, which is kind of a truism articulated within the engineering community. So some of the problem areas that we see with technical solutions overlaid on humans in the loop, so to speak. Technical solutions come in layers and increase system complexity. Technicians without proper training will be unable to use the BAS system to problem solve and manage complex sequences of operation. Sensors will drift, resulting in system drift and lost efficiencies. We estimate that within 6 months, ASHRAE 36 will have lost most of its effectiveness due to sensor drift, unless, of course, the building operator is able to calibrate or recalibrate sensors every 6 months. Technical solutions are also superimposed over traditional firefighting culture of building operations. That is kind of the dominant culture at an organizational level and a behavioral level. And finally, automated solutions will be overridden to address operational needs. So what our project did is it developed a certification strategy called High Performance Building Operations Professional to try to impact ultimately the behavior, the knowledge base and skill base, especially cognitive skills of building operators, building engineers, facilities operators. It builds upon a substantial body of research, and there's a huge amount of research about standard practices. ASHRAE 180, for example, Department of Energy funded a number of studies looking at standard practice. And what we did with this work is we began to try to look at what are high performance practices and what is the delta between those two. We began back in 2011 or so with really what were ethnographic studies, case studies, and moved from there into a very detailed analysis of high performance building operations. And we have a DACM on our website, and you can look at that and so on. What we recognize is the need for broad mechanical and electrical knowledge, which we would expect, plus advanced cognitive skills. So a lot of these skills are thinking skills, not wrench turning skills at the operations level. We recognize the need to improve education and training. And finally, we emphasize the critical importance of using the BAS system effectively. So Some of our goals with the certification: create a standard of knowledge and cognitive skills for high-performance building operations technical professionals. We're establishing an ISO 17024 aligned and accredited certification. We're developing curriculum guidance for two-year colleges and other training providers. And we're supporting the effort to align curricula with high-performance standards. This is an example of some of the higher level knowledge and cognitive skills that we're looking for. Understanding systems as opposed to components within a building system, and understanding how systems how the system operates as a system. And that when you tweak a component somewhere, it has effects elsewhere in that system. And you apply that systems approach to environmental management, develop systems manuals, very critical function, use effectively the BAS system, understand energy conservation, audits, measures, implementation, understand commissioning, M&V, and finally, commit to continuous quality improvement. So these are the essential higher level cognitive skills that we believe operations technical staff need. And this is a big challenge to bring people from where they are currently to where they need to be. Just a quick example of some of the applications for building automation control systems. And you can see there the use, for example, of displays and graphics. BAS systems have an amazing ability to produce lots and lots of data, and technicians have to be able to look at and interpret that data and use it to problem solve. Looking at alarms, looking at overrides. Often overrides are put in systems and they're never removed. Occupancy schedules, a lot of these functions save energy if they're carried out. But if the technician doesn't know how to use the automation system to carry out these functions, energy will not be saved. The occupancy schedule and the equipment schedule will be not aligned. And that is often the case. So I'm going to close there and turn it back to you, Praveen.
Okay. Well, thanks, Peter. Thank you to all three of our speakers. And I'm now going to open up the floor to questions. And I'm going to start with asking the questions that we received in the chat. And there's a lot of interesting ones, from sort of details to big picture questions. I guess let's go in the order of our speakers. So George, my first question is to you. So this is sort of a group of questions. Colin Weigel asks, how many households were included in your tests? Also notes that it was a great presentation. Susan Vargas, our most prolific questioner, asks, are users self-identified or classified based on their behavior in the program? And to add my own question onto that, do you have any demographics of who is a saver, who is a person that falls into one of these other categories? So do you think you can talk a little bit more about people and their categories?
Yep. So let me give also a little bit information about what Home Connect is and what a demand response event, which was one of the questions. Okay, so Home Connect is an aggregator. I don't know how many customers they have in California, but California and Texas, they have about 180,000 households. And what they do is they compensate consumers for savings during events that are called by utilities. And in California, the area they serve is covered by 5 utilities. So some of those may have fixed rates, some of those may have time of use rates. These are information that they do not have, but you can assume a mix of everything. Okay. Now to the specific questions about how many households. This was 217 households. over a period of 3 months. So it's not many homes, but there were about 5 events per home for a total of 1,170 something events called by a utility. So an event is a utility says between 7 and 7:30 today, kind of like I want you to reduce consumption, and if Home Connect succeeds to do it on an aggregate, then they're compensated. Okay. So the data, so even though it's only 200 some homes, the data is enough to bring statistically significant conclusions. On savings and non-savers, yes, this is kind of like self-identified based on the results. Loosely, it is the top quartile is the savers, the bottom quartile is the non-savers, and the kind of like 25 to 75 is the kind of like we don't know category. We have not looked at demographics. Okay, that's a great idea. Kind of like to close with the statements, kind of like the vision for SANS is, with limited, so it's a great outreach, what we did, okay? So we put a lot of effort to recruit 200 households, but 200 outcomes times 300 watts per hour is a small outcome, okay? Our excitement happens when kind of like next year, National Grid starts a deployment in New York, where we're gonna be available for free to every consumer that is willing to connect to Wi-Fi. So our outreach could potentially reach millions of homes. And then is when the fun begins, because this is going to be the first time that you will have the large population with access to real-time information, which is something that hasn't happened before. So that's what we're looking forward to.
Well, thanks, George. That was a very thorough answer. So Shelby, let's turn to your presentation. Also super interesting.
Thank you.
Isabel Coupe asks, I hope I pronounced that name properly. It'd be interesting to see how people behave with a regular strip after they're informed of the savings benefits of the smart strip. Would they be more cognizant of their actions since they know the exact benefits of turning on and off equipment?
I would like to say yes. That's kind of a complicated thing there, because a lot of this engagement program comes with the side of education, right? So what we're trying to do is make estimates of the actual energy savings that are very quantifiable, and then we don't really have a great idea or a grip on what the behavior energy savings are accounting for. So I would like to say yes, because we're going in, we're talking to people that have those 2 1800 watt space heaters that they never turn off, and we're saying, one, this isn't safe to leave on 24/7, even when you're gone on holiday. You're trying to increase the ambient temperature of your space, but your thermostat is reacting to that. It's reading at 5 degrees over your supposed set point, and it's starting to send you cold air. So it's just this vicious cycle that they're creating, but they don't know. So a lot of the education is like, oh, maybe if I were to not do this and see what my baseline is, I can make behavior changes, like having a office blanket or another sweater, or if you run cold, just finding solutions that work specifically for you instead of changing your overall office, and unfortunately sometimes making your co-office share really uncomfortable as well. So a lot of it's social issues, a lot of it's teaching them what's actually going on in the background as to why they may be uncomfortable, and then they are taking that with a grain of salt and making those changes. I'd like to think that if we were to take out all of the smart strips, that people would remember to turn off their devices at the end of the day and unplug these things when they're not in use. But it is just it's a nice little safety net that ensures that we're doing what we need to do to reduce that energy use, and ultimately teach them along the way how to make themselves more comfortable and be independent in that way.
Mm-hmm. I know in the environmental psychology world, people often ask, if we take the behavior out of people's control, do they not learn to change their behavior? So that's something I think is interesting to think about.
It's a fun dynamic for sure. Yeah.
And so Peter, moving to your presentation, Susan Vargas asks, sophisticated building control sequences are a double-edged sword. do you think that there's a trade-off between optimization and simplicity? As we're talking about human action here, optimizing obviously is important, but then making it simple allows the humans to use it as easily as possible.
Well, that's one of the central issues, yes. And typically, if the human is not able to use the equipment, especially the BAS system, is not able to look at the sequences of operation and actually understand them, write them even, they will tend to simplify. And so that's why we're working so hard on this certification, to make sure that we begin to focus the spotlight on the technician who is using these systems and to help them be more effective. Otherwise, she is right. There is this truism in the industry that people will simplify the system to their level of understanding. A chief engineer we've seen in the past will shut down the entire BAS system because they don't understand it. Now, I think that individual was fired later, but it's the extreme case. But what we see is that people will shut off parts of the system that they don't understand, and they will override. So the notion that we can automate the whole thing and walk away, take the human out of the loop, I think is one of the great fallacies here. We need to bring the human up.
I think that's a theme we're seeing among all three presentations today, that we can't just zero out the human factor here. There's always going to have to be a human plug-in that we need to work with, not deal with. But humans are never going to be zeroed out of the equation.
It's really Industry 5.0, I think, is pointing in that direction, that we have to bring the human back into the loop and understand their role is fundamental.
Absolutely. And so, George, I'm gonna pivot now to you. And so this is, I guess, a pretty specific question. When it comes to my understanding is that this comes from Colin Weigel. Sorry, Colin, I know I mispronounce your name every time. Colin is a former panelist at BECC, by the way. Since savers are identified, or the category of users is identified per event, are you able to see if savers in one event are likely to be savers in future events? Right. So is that sort of a trait as opposed to like just an event specific thing? Do you have any thoughts on it? Are you able to see that? Sorry, you'll have to unmute yourself there. Yep.
Yep, sorry about that. So no, they were not identified per event. They were identified over the period, okay? So a saver was the top 25 percentile of households over the 3-month period. So we do not know, unfortunately, the test, sorry, what happened here? Unfortunately, the test was short enough that we would not see long-term behavior. Over these 2 months, we did not see a decay in the amount of savings. The data was very noisy, it's still a small sample, but this is, look, we absolutely need to do what Colin suggests. So if we want to affect a large population, we need to understand not only the dynamics of behavior, but the dynamics of messaging that they can respond to over a long period of time, because that's what we want. We want sustained savings and not kind of like a quick one-off that does not sustain over time.
Thanks. Shelby, I have a question. I'm going to kind of combine my question in with a question from or a comment by Paula Latassa. So Paula notes that your work is really promising, and she hopes that this program catches on with other universities and businesses, which kind of brings me to my question. Smart strips are great if people buy them, if people install them, and if people don't uninstall them and continue using them.
Sure.
Have you thought about those problems? Like, how do you deal with them? What's preventing people? Like, what do you think?
Yeah, so I mean, we obviously look at our worst case scenarios, and I have a lot of fun personally just showing up at people's offices and say, hey, what's going on here? Like, you've been reported by your energy champion of this department saying that you may not be the best, behaved or you're not showing those pro energy behaviors that we're looking for. What's going on here, and can we have a talk about it? And our mission of this program is really kind of hitting people from the bottom up, like climbing that ladder, talking to occupants, getting them on board on a social level. We have a lot of students that go out and are friendly faces, and I think they kind of play the role of, hi, I'm a student and trying to like do my job. Will you be willing to help me? And then I can also come in throwing my little heavier hammer there, trying to get people to be on board and excited about this, while facilities is coming from the top down, trying to address those operational issues. And somewhere in the middle, we're hoping that overall that middle pillar of our program being that we're building a community where people actually understand what's going on and they care about it, to achieve those higher savings or that higher energy saving potential. I can't say that if we weren't there actually engaging with folks on a face-to-face basis that this would be as successful. But if we were to expand this as a framework that other companies or other universities were able to use and actually get very significant savings, as we are seeing so far as our estimates, that's really significant. And we think that it's important to talk to people, keep them happy while these other factors are at play, trying to help the building themselves. So we feel that it's really important to be on the ground and working with folks. Some people may not want to do that, and certainly the building operators, if they're engineers or other very scientific minded folks, they may not know how to communicate that. So we work a lot with the humanities and the social sciences in order to get that messaging right.
Mm-hmm. That's, I think it's really interesting, because we always think about how to scale these programs, and obviously the more personal your approach is, the more likely you are to be successful.
Mm-hmm.
And as we get bigger and bigger, we need to think about how impersonal, so to speak, can we get and still have an effect. So
right, yeah, and it does take a lot of manpower. We have a good amount of students walking around and doing their check-ins, and we have our newsletters, and we're kind of in people's faces maybe a lot more than they would like, but it's the only way for us to keep a pulse on things. And it's beneficial for us. I know that we get a lot out of it, and I hear a lot of crazy stories of people that left during COVID and haven't been back to their office and never unplugged their space heaters or their coffee machines, and started safety risks at that point. So it's a lot of learning. It's a lot of being hospitable and comfortable with those uncomfortable conversations, and not going in and I'm going to take your space heater and being the bad guy, but saying, I understand why you have this and why you're uncomfortable. Let's see if we can find you a solution. And scaling that could be a challenge, but we're doing our best for now.
It sounds like the type of intervention is really well suited to the university setting.
Mm-hmm.
And actually, Peter, it's kind of related here. I was hoping that you could tell me a little bit more about the firefighting culture in buildings that you talked about. I know that I've had this experience too. I've worked with healthcare facility workers where they say, when the patient is cold, drop everything else, crank the heat in their unit, and sometimes that gets left and people forget to crank it down when the patient leaves. But why is it important to have a sort of what is a firefighting culture, and why is it detrimental to EE or energy efficiency, and how do we combat that?
Well, perhaps the origin of the firefighting culture is almost a systems a metaphor that Peter Senge and his group developed, fixes that fail. And one of the first places people look to cut their budget is in the operations and maintenance staff. And so we had an interesting comparison. Somebody compared the IT department with the maintenance department, and how well staffed IT is by comparison, because everybody uses computers and they understand, oh, that's really important. Everybody also breathes air and, needs to use those other systems, although it's largely invisible. So the firefighting mentality comes from basically a stream of incidents and we don't have enough people to be proactive, and so we're reactive. And it's fundamentally a reactive mode of operation. And so we just react to one event after the next. And we are never able to optimize or to improve, et cetera. And so it as an organizational culture, it's very ineffective and yet very prevalent. And it's part of what we have to turn around and change in order to do the kinds of things we want to do with commercial buildings for the future.
Thanks for that. So we have 3 minutes left, and I do have a few other questions that we couldn't get to, so I apologize to the people who asked those questions. Those are being excellent to really seed our conversation here. With the last 3 minutes we have, I would love each of our speakers to just say, one message they want to leave us with, relevant to your work or anything. We'll start with George, and then we'll go with Shelby and then Peter.
So my statement is that everybody says that consumers don't care about energy and energy is boring. And what we found at Sense is if you give them real-time actionable information, not paper about what they did last month, then they dig deeper and try to find out what's happening. So very excited about the future.
Thanks, George. Shelby, sorry to put you on the spot here.
No, this is a good conversation starter. And I mean, I work with people a lot, and it's kind of my passion at this rate of, you have to understand what's actually going on with them and the reasons that they're making these decisions and doing their behaviors before you can actually help them find a solution that works for them. And typically once you hear them out and they feel like you're not out there to get them, that's when that change and that willingness to participate really happens. So I encourage people to consider people in their equations when they're talking about energy efficiency.
Thanks, Shelby. And Peter, you want to round it out here?
Okay, thank you. I would just say knowledge is power, and energy awareness is transformative. And we have to put the human back in the loop. And I think all of our messaging has been about that today, and give people the information they need to make more intelligent decisions and do better.
That's perfect, and really does sum everything up very well. Thank you to our 3 speakers, George, Shelby, and Peter. It's been fantastic. Reminder, if you are interested in this kind of topic and you want to hear more, come to the BECC conference, which is coming up very, very soon. And do register before the end of the month because prices go up and you don't want to miss out. We have a virtual opening day on November 9th, followed by 3-day in-person extravaganza. So looking forward to seeing you all there, and we're going to sign off now. Thank you so much.